Alrighty, today we are going to start covering the transition metals on the periodic table. If you do not know what the transition metals are, when you're looking at the periodic table, they are essentially this little block right here in the center. So all of group 3b to 2b are the transition metals. Now, if you've been noticing for ionic bonding, none of the practice problems that we've been working with have dealt with these transition metals, and that's because of the fact that it's kind of hard to tell how many valence electrons are being lost with these transition metals. So now we're actually going to figure out a way to solve for that amount and be able to calculate the charges of our transition metals. So to start off with, transition metals are still metals. So they're going to behave similarly to every single other metal. They're going to lose electrons and become cations, and they're only really going to engage in ionic bonding. Remember that ionic bonding is between a metal and a nonmetal. Transition metals obviously cannot engage in covalent bonding because that only involves nonmetals. Now, as previously stated, the transition metals are going to have different charges based on different energy levels. Now, we're not going to get into the nitty-gritty of that. That's for another lesson, mainly in electron configuration. But just know that transition metals can have different charges. And the way that we denote that is by adding a Roman numeral next to the name. So when you write the name of a transition metal, immediately after you write its name down, you'll place a Roman numeral right next to it. That Roman numeral will directly tell you the charge that that transition metal holds. So a common example is iron, which is Fe on the periodic table. Now, iron can exist in one of two ways. It can either have a charge of positive 2 by losing 2 electrons, or it can have a charge of positive 3 by losing 3 electrons. So when you're referring to the iron cation, you have to specify which one you're referring to, because iron cation can mean either of these two things. So if you wanted to write down the formula for iron 3 or the name of it, it would be very simple. All you do is write down iron followed by the Roman numeral 3. What this Roman numeral 3 shows you is that iron has a 3 plus charge. For the other ion, iron 2, all you would have to do is write down iron 2. That 2 immediately after iron shows you that iron has a charge of positive 2. Everything else works exactly the same, so you're going to put iron next to an anion, and then you'll crisscross the charges, and from there you will form an ionic compound. Now, if you don't already know, here are the Roman numerals that you'll potentially see. So I would be positive 1, 2 I's is positive 2, 3 I's is positive 3, IV is 4, V is 5, VI is 6, and VII is 7. And rarely will you ever go anywhere above V. These are just a precaution. So now, go ahead and pause the video and try out these practice problems. Remember that for the transition metals, you're going to need to use the Roman numeral to get the charge of it. And for the anion, you would simply use the periodic table. Okay, so that should have been enough time, hopefully if you paused it. So let's go ahead and run through all these. Copper 2 chloride. Copper is Cu on the periodic table, and this 2 right next to it stands for 2 plus. So copper has a positive 2 charge. And then chloride, if you look through the periodic table, you'll see that it has a negative 1 charge. If you don't know how to get that chloride has a negative 1 charge, you should go back to the cations and anions video where this is explained. Then after you have these two charges, all you do is crisscross them. So the 1 goes under Cu, the 2 goes under Cl. So you end up with CuCl2. Iron 3 oxide, this means that iron has a 3 plus charge, and if you look through the periodic table, you'll see oxide has a 2 minus charge. Once again, all you have to do is crisscross these charges. So the 2 goes under Fe, the 3 goes under O. So you end up with Fe2O3. For cobalt 2 fluoride, cobalt has a positive 2 charge because there's a Roman numeral 2 next to it. Fluoride has a negative 1 charge. Crisscross these charges and you end up with COF2. Titanium 3 nitride. Titanium is going to have a positive 3 charge. Nitride, if you look through the periodic table, will have a negative 3 charge. Because these are the same exact charge, they're just going to simplify out to ones. So this will be TiN as opposed to Ti3N3. Vanadium V phosphide. V is for 5, so that means that vanadium has a positive 5 charge. Phosphide, if you look through the periodic table, has a negative 3 charge. When you crisscross these, you'll end up with V3P5. And then lastly, lead 4 sulfide. Lead is Pb. The 4 next to it stands for the fact that it has a 4 plus charge, and sulfide is going to have a negative 2 charge. When you crisscross these, you'll end up with Pb2S4, but whoops, look at that. These are common factors of each other, so you're going to simplify both of these by 2. So this is really going to be PbS2. Okay. And that really does it for writing formulas for transition metals. All of these do have a Latin name associated with them, but those will not be covered in this video right now.